Dear students, today we will study about rate of convergence for method of false position or Regula-Falsi method. Okay. Let us assume that fx equal to 0 be the given algebraic and transcendental equation. Suppose this is the given an equation, and suppose alpha be the exact root of equation fx is equal to 0. If alpha is the exact root, or we can say value of f alpha must be equal to 0. Okay. Now we will see how geometrically method of false position or Regula-Falsi method works. Suppose this is x-axis, this is y-axis. Suppose this is the given curve, y equal to fx, and suppose when this curve crosses the x-axis, in that point here value of y will be 0, means here we get exact root, and suppose this is the exact root alpha. Okay. Now by the intermediate value property we can find out these 2 points. So we can locate the position of the root. Suppose this point is xn minus 1 0, and suppose that point is xn plus 1 0. Okay. In Regula-Falsi method we find out equation of chord joining these 2 points. Here coordinate of A is, here we can say coordinate of this point is xn minus 1 and fx n minus 1, and coordinate of, suppose this is the point B, and coordinate of this point is xn plus 1, and suppose xn, suppose this is not xn, so xn and fxn. Okay, and this is the first approximated root xn plus 1. Suppose this is the first approximated root xn plus 1. Okay, here xn will differ from alpha y and error epsilon n, where epsilon n is very small quantity. This is very small quantity, means it is differ by alpha, means epsilon n equal to xn minus alpha. Okay, we can write it equivalently. xn is equal to alpha plus epsilon n. Also we can write it xn plus 1 equal to alpha plus epsilon n plus 1, and xn plus 2 is equal to alpha plus epsilon n plus 2. Okay, now by the Regula-Falsi method Now from method of false position or Regula-Falsi formula, method we have, suppose root is lies between, suppose f of a into f of b less than 0, means root lies between a and b, then first approximated root we can calculate by the formula. Suppose this is the point x1 and x2, suppose this is the point x1 and this is the point x2, and first approximated root we can find out by the formula x1 fx2 minus x2 fx1 upon f of x2 minus f of x1. Okay, suppose here root is lies between, here we assume root is lies between xn minus 1 and xn. Okay, means suppose for this problem f of xn minus 1 and f of xn less than 0, then what we get here? Here xn plus 1 is equal to xn minus 1 fxn minus xn f xn minus 1 upon fxn minus fxn minus 1. For the simplicity we can take xn plus 2 in place of x plus n for the purpose of simplification, for the easily understanding the problem. We take here xn plus 1 in place of xn plus 2 in place of xn plus 1. We can write here xn fxn plus 1 minus xn plus 1 and f xn upon f xn plus 1 minus xn. Suppose this is the equation number 1. Now first we have to understand what we have to find out, है ना? What we have to find out, what we have to find out. Here we know that we have to find out equation 1 in the form epsilon n plus 1 equal to a into epsilon n to the power k. Actually we have to find out the rate of convergence. We have to find out rate of, here k is the rate of convergence. Okay, we try to convert this equation 1 with the help of these substitution in this form, so that by comparing these two we can find out the value of k. In any kind of iterative method, we can say an iterative method is said to be of order k or has the rate of convergence k if k is the largest positive real number for which there exists a finite constant. Here capital A must not be equal to 0 such that epsilon n plus 1 equal to A into epsilon n to the power k, where epsilon is a very small quantity. Okay, we have to find out this thing. Now from 1, now we put the values of xn, that is alpha plus epsilon n, xn plus 1, that is alpha plus epsilon n plus 1, and xn plus 2, that is alpha plus epsilon n plus 2 in equation 1. When we put all these values, what we get here from equation 1, xn plus 2 is equal to, here we have to put also value of xn plus 2. What is xn plus 2? Xn plus 2 we can write here epsilon n plus 2 plus alpha. Okay, what is xn? Xn is equal to alpha plus epsilon n function of xn plus 1. Xn plus 1 means alpha plus epsilon n plus 1 minus xn plus 1. Xn plus 1 means alpha plus epsilon n plus 1 into function of xn equal to alpha plus epsilon n, and whole divided upon f of x plus n, that is f of alpha plus epsilon n plus 1 minus f of alpha plus epsilon n. Okay, all these values of xn, xn plus 1, xn plus 2 in this equation 1, we get here this relation. Okay, now we solve this equation, that is epsilon n plus 2 plus alpha is equal to, now we multiply this term by this term, we get here alpha into f, alpha plus epsilon n plus 1, and what is the second alpha term? Minus alpha, this term into this f alpha plus epsilon n, plus we multiply this epsilon n by this term, we get here plus epsilon n, we multiply this by epsilon n here, f alpha plus epsilon n plus 1 minus epsilon, this epsilon n plus 1 into this, minus epsilon n plus 1 into f alpha plus epsilon n, and whole divided upon f alpha plus epsilon n plus 1 minus f alpha plus epsilon n. Okay, now we take another page. we have to simplify this term. See here. Here we have epsilon n plus 2 plus alpha. Okay. And this is equal to, here alpha is the common term. Alpha, if we take alpha outside of the bracket, we get alpha plus epsilon n plus 1 minus f alpha plus epsilon n, and these two will be cancelled out. Okay, this term upon this term plus this term upon this term, and we take alpha as a common term, and means we get here f of alpha plus epsilon n plus 1 minus f alpha plus epsilon n upon this term, means these two will be cancelled out. We get only alpha. Okay, alpha plus what is the second term? This will be cancelled out. Epsilon n f alpha plus epsilon n plus 1 minus epsilon n plus 1 and f alpha plus epsilon n. This upon f alpha plus epsilon n plus 1 minus f alpha plus epsilon. Okay, now these two will be cancel out. Now epsilon n plus 2 is equal to, now here we have to apply, we have to expand all these four terms 1 2 3 4 with the help of Taylor's theorem. Okay, now we expand all these, all four terms, this that, okay, by the Taylor's theorem. Now first we expand this term. Here epsilon is that, n is the common term. Alpha plus epsilon n, this is equal to f alpha plus epsilon, here we have n plus 1, epsilon n plus 1 upon factorial 1 f dash alpha plus epsilon n plus 1 whole square upon factorial 2 f double dash alpha plus log l plus 1 whole cube upon factorial 3, and this is f triple dash alpha. Now minus, now second, what is the second numerator term? It is minus epsilon n plus 1. This is the common term, and we have to expand this by Taylor's theorem. Okay, so we get here f alpha plus epsilon n upon factorial 1 f dash alpha plus epsilon n square upon factorial 2 f double dash alpha plus epsilon n factorial 3 f triple dash alpha, and so on here, and so on and so on. Okay, this is the expansion in of numerator terms. Now we expand the denominator's term. Denominator term is f alpha plus epsilon n plus 1 minus f alpha plus epsilon n. Now we differentiate this. Okay, f alpha plus epsilon n plus 1. Here epsilon here epsilon, here we expand this. What we get here? We get here f alpha. First we expand this term f alpha Okay, plus epsilon n plus 1 upon factorial 1 f dash alpha plus epsilon n plus 1 whole square upon factorial 2 f double dash alpha plus epsilon n plus 1 whole cube upon factorial 3 f triple dash alpha and so on, minus we have to expand this term by Taylor's formula. What we get here, f alpha plus epsilon n epsilon n upon factorial 1 plus epsilon n whole square upon factorial 2 f double dash alpha plus epsilon n whole cube upon factorial 3 f triple dash alpha and so on. Okay, now here we have expand all four terms with the help of Taylor series. Okay, and here we know that alpha is the exact root of the given equation, means f alpha is 0, and here epsilon n is a small quantity, means the square of higher terms means epsilon n whole cube, as all will be cube and higher will be very small, means we can neglect the higher power of epsilon n square, epsilon n whole cube and so on. Okay, means neglecting higher powers that is epsilon n whole cube, epsilon n 4 we neglect. Okay, now epsilon n plus 2, now all these terms will be 0. See here, all these terms will be 0, and here that is multiply this. Okay, what we have here, here we have epsilon n, all these terms are 0, means epsilon n and f alpha 0, this term 0, this term 0, this term 0, this term 0, means what we get here in numerator epsilon n into epsilon n plus 1, f alpha is 0, epsilon n plus 1 f dash alpha plus epsilon n plus 1 whole square upon 2 f double dash alpha. Okay, minus neglecting, now we neglect the all these terms because they are very small. Next we write epsilon n plus 1, epsilon n plus 1, this term is 0, epsilon n f dash alpha plus epsilon n plus 1 and epsilon n plus 1 epsilon n f dash alpha plus minus this is the common term. Okay, here we can write this term in a bracket, means, or we can write here negative term, minus epsilon n plus 1 into epsilon n square upon 2 f double dash alpha, and other term will be 0 because they are the higher power of epsilon n, and we can neglect this. This is the numerator term. Now what we get in denominator? In denominator we get here f alpha will be 0. Here we have epsilon n plus 1 f dash alpha plus epsilon n plus 1 whole square upon factorial 2 f double dash alpha. Okay, n plus f double dash alpha, neglecting this term, minus this is 0, epsilon n f dash alpha, and minus what we have here, epsilon n square upon factorial 2 f double dash alpha. Okay, now we simplify it. Here few terms are cancelled out. Here we can see here epsilon n plus 1 f dash alpha, this is cancel out with this term. Okay, what we get here, epsilon n plus 2 is equal to epsilon n plus 1 whole square upon 2 f double dash alpha. This is the common term. What we have inside the bracket, we have epsilon n plus 1 minus epsilon n. This is the term we have in numerator, and in denominator, what is the common term? Here from these two, f dash alpha is the common term. We have epsilon n plus 1 minus epsilon n, and here in these two we have f double dash alpha upon 2 is a common term. Here we have epsilon n plus 1 square minus epsilon n whole square. Okay, now we simplify it. What we get here, we have epsilon n plus 1 whole square f double dash alpha, and we have epsilon, here we have epsilon n plus 1 minus epsilon n, this upon what we have here. Here we can replace this term by, here we can apply formula of a square minus b square, that is a plus b, a minus b. A minus b means epsilon n plus 1 minus epsilon n. We can take out as a, this is the common term, we can take out outside of this bracket. Okay, what we have here, we have 2, this 2 we write here, and common term is epsilon n plus 1 minus epsilon n, and inside the bracket we have f dash alpha plus f double dash alpha upon 2, and here epsilon n plus 1 plus epsilon n. Now these two are cancelled out again. Here it is, we have to very much focus here, otherwise it's a very lengthy derivation. Now we have epsilon, this is n plus 2, epsilon n plus 2 is equal to epsilon n epsilon n plus 1 whole square upon 2, and here we have f double dash alpha upon f dash alpha 1 plus f double dash alpha upon 2 into f dash alpha into epsilon n plus 1 plus epsilon n to the power minus 1. Okay, now we have to expand this with the help of binomial theorem, this term. Okay, now we write here epsilon n plus 2 is equal to epsilon n plus 1 square upon 2. Here we have f double dash alpha upon f dash alpha, and when we expand this 1 plus x to the power minus 1 is 1 minus x plus x square and so on. Here we have term 1 minus f double dash alpha upon 2 f dash alpha, and here we have epsilon n plus 1 minus epsilon n, and neglecting the higher terms. Okay, no need to write down all the terms, and also we will neglect here this term also. Here we are neglecting this term, we are also neglecting this term. What we get here after neglecting this term? Okay, now we get here epsilon n plus 2, which is approximately equal to epsilon n plus 1, and here when we multiply this term to here in 1, this is we are neglecting this term, and we multiply this here, what we get? Here we get f double dash alpha upon 2 f dash alpha. Okay, and suppose we are writing this, suppose this is